In this video, we are going to talk about this assembly program that computes the factorial of a number. So let's get straight into our program. We have this include asmio.inc in line 8, which we'll be needing, and printing out the results and at the same time the instructions for the users since our NASM doesn't have this feature. Next, we have this segment.data block, which includes three labels, the message 1, message 2, and message 3. So message 1 is printed out at the beginning of our program, and the next two messages, which are message 2 and message 3, will be used in the results. In segment.pss, we have these two labels. We have the input 1 and the fact value. Input 1 will store the number entered by the user, and fact val will store the factorial value of input 1. In line 22, we have the segment.text, which we set our ASM main to be global in order to run this program in a SAP. So now we formally start in our function or in our main function. So we have this enter 00 push A, which is a setup routine. So this is like the default entrance of our program or our function. In line 29 to 30, we just simply print out the starting message, which is the enter a number to calculate its factorial number. Next, we call in this read integer, and this will simply get or pick the integer entered by our user and store it in our input 1, which is found in our line 32. In line 34, we have this push D word input 1, which pushes 32 bits from the memory location input 1. And in line 35, we insert a value of fact val in the stack. So as you can see, we have brackets here, and here we do not have. Since in here, we're just directing or telling our program that it will act as a pointer. In line 36, we're just simply calling the function that we have defined here at the bottom that we'll be discussing later, and we add ESP with 8. So in our line 60, we have this segment.text. In line 61, we have this get fact value or get fact function, I mean. In line 62 and 62, we pushes EBP to the stack. In line 63, we move the value from ESP to EBP. So the new value of EBP now is equal to ESP. In line 65, we have this move EAX EBP plus 12. So what we are doing here is EAX acts as a pointer to value 3 layers after the value pointed by ESP. In line 62, we simply set the value of EAX to be stored in our ECX register. And in line 67, we just simply decrease the value of our ECX. We decrease it by 1. So what this function does is, because it's a factorial number, so if we're asked to get the factorial of 5, so what we are doing there is we are multiplying 5, 4, 3, 2, 1. So as you can see, there is a decreasing order by 1, and this one is responsible for giving us these numbers or integers or factors that we'll be using multiplying later on. In solve fact, we have this I multiplication. So this is a multiplication function which multiplies EX and ECX. So as you can remember, the ECX here will be collected or will be from this function. And we are multiplying the EAX. So for example, the value here is 5. It will 4. It will be multiplied by 5. So 5 times 4. The next value here is 3. So the value or the product from 5 times 4 will be multiplied by 3. And it just keeps on repeating until it reaches the value 1 or 0. Or 1, I mean. In line 73, we just simply get the address EBP plus 8 and pointed by the EPX. In line 74, we save the value of the EAX to the memory. So this is the memory now. And just simply leave and call the ret function. So ret here is a non-conditional jump to the next instruction. So going back here in line 42 in our printing out of results, in line 42 to 43, we just simply printing out the message 2, which is factorial of. So this is the results part now. In line 44, we have this move EAX input 1, which stores the value of the number entered by the user, and we call on the print integer to print it out. In line 46, we also did what we did here, like calling out the message 3, but here it's the word is. This one. This is message 3. And in line 48, we set the value of EAX to be the value that we got from our fact file, and we print it out. So in this part, we're just simply printing out the results. In line 51, we are calling a print new line. In line 52 to 54, just flushes the value out of the 32-bit registers. So we've used these three values, or three registers, I mean. And at the end of our program, we make sure that we return it into their default values, which are 0. And we just pop A, leave, and red. So this is the how we make this function that will give us factorial numbers. So let's now check if it'll give us the results that we are looking for. So we're just gonna compile this one. And now we're just gonna call in the ASMIO. So we have this lab6.asm, and now we're gonna compile this. Now we're calling our lab6. So we're gonna get 5, and the answer is this one. So that is correct, since if we try to search for the value of factorial of 5, it will give us 120. What if we get the factorial of 10? So as you can see, this program is working, and that is all for this video. Thank you for watching.